Good afternoon, everyone. So now we are discussing about adders. So in our last class already we have discussed about half adder and full adder, but now I would like to explain you about parallel adder. So see here, while coming to the parallel adder, it is used to add two nibbles or two bytes at the same time. Not a single bit is added to the single bit. Two bytes or two nibbles. For example, while coming to a nibble, 1 0 0 0 is a nibble and 0 1 1 1 is also an other nibble. So here we would like to add 0 plus 1 1 0 plus 1 1 0 plus 1 1 0 plus 1 1. So this is the addition. It is a kind of parallel addition. Parallelly more number of bits will be added at the same time. Either maybe it nibble to nibble, or it may be byte to byte, or maybe 6 bits are added to the 6 bits, 7 bits. Means here you consider these bits are represented A0, A1, A2 up to AN and B0, B1, B2 up to Bn. So here one set of binary bits are added to the other set of binary bits at the same time, so that the speed must be increased. The speed of addition must be increased. So in our last classes we have discussed about half adders and full adders, but half adder will add two individual bits at the same time, like 0 plus 0 or 1 plus 1 individual bits, 0 plus 0, 1 plus 0, 1 plus 1. But while coming to the parallel adder, here bit to bit or byte to bytes or 2 bytes at the same time will be added. So this is the speciality of 4-bit parallel adder. The name itself indicates parallel adder. Number of bits must be added at the same time. How many number of bits will be added? 4, 5, 6, 7 up to infinity number of bits will be added at the same time. Especially it is used for bit to bit addition, means nibble to nibble. 4 bits are added to the 4 bits, 8 bits are added to the 8 bits. So here it is a 4-bit parallel adder. So simply it is called also a nibble adder. 4-bit parallel adder. 4 binary bits will be added to the remaining 4 binary bits. Now see here, it is a circuit that can add 2 binary numbers. Okay, 4-bit parallel. So like this. So AI, BI. So here AI means A0, A1, A2, A3. It is one nibble, and B0, B1, B2, B3. It is some other nibble. And here while adding bit A0 and B0, some S0 will be produced and carry C0 will be produced. By adding these two bits, some S0 will be produced and carry C0. Next, by adding the bits A1, B1 and carry C0, some S1 is produced and carry C1. In next stage A2, by adding A2 and B2, some S2 and carry C1 is produced. So in this way, at a time we are going to add 3 bits at the same time. Okay, at a time here we would like to add 3 bits, 3 bits, 3 bits, 3 bits. So in our last class we have discussed about an arithmetic logical circuit is there that is used to add 3 bits at a time. Which circuit? Full adder. So that means what? Here a single parallel adder does the function of 4 full adders. How many number of full adders are there here? 4 full adders are there. To add 3 bit sets, 4 sets are there here. So it will do the function of 4 full adders at the same time, so that addition of speed will be increased. See here in slide A3, A2, A1, A0. So here A is urgent, means infinity number used. B is also one addend. So here some S3 and carry will be produced. So while coming to the block diagram, so this is the block diagram. Okay. So how many number of full adders are there here? 1, 2, 3, 4. So numbering is started from 0, 1, 2, 3. So see here the bits A0 and B0 will be given to the full adder 0, so that it will produce some S0 and carry C0. Okay, and whatever the carry C1 is produced, from the full adder, it acts like one of the input to the full adder 1, means carry of the first stage will be given to the input of the next stage, one of the input of the next stage. So here full adder 1 containing the 3 inputs A1, B1, C1. So these 3 are the inputs. By adding these 3 bits A1, B1, C1, we are getting some S1 and carry C2. So some S1 is there in our result and carry will be added to the next bits. So our next bits are A2 and B2. So here A2, B2, C2, these 3 bits are added and produced some S2 and carry C3. And this carry C3 is added to the next full adder. So that is full adder 3. So for the full adder 3, A3, B3, C3 is connected. According to full adder logic, these 3 bits must be added and produce the sum S3 and C4. So in this way, 4-bit parallel adder will add the 4 bits, means 2 nibbles at the same time. By adding A0, B0, we are going to getting some S0 and carry G3. Adding A1, B1, some S1 and carry C2. By adding A2, B2, some S2, carry C3. But while adding 2 bits, carry also will be added. Previous stage carry also will be added. So simply it will do the function of full adder, one full adder at one stage. So how many number of full adders required here? If it is a nibble, 4 full adders are required. If it is a byte, 8 full adders, means depends upon the addition, number of full adders must be required. So here one merit is there, speed of addition will be increased. At the same time, one demerit is there, each and every stage requires one full adder. For example, if we are going to add n number of bits, there is a need of n number of full adders. Cause of that, the circuit becomes complex and it is also expensive. But one merit is there, the speed of addition will be increased compared to the half adder as well as full adder. Okay, and while coming to the next one, so once see with example I would like to explain. So here A is equal to 1 0 1 1, B is equal to 0 0 1 1. So first I would like to add these 3 bits 1 0 1 1 and 0 0 1 1. 1 0 1 1 1 1 0 1 1 as well as 0 0 1 1. So see here, by adding 1 and 1 we are getting 0 sum and carry 1. By adding 3 ones, 1 and 1 next, and also we are getting 1 here 1. So this is our answer. But see here, after first addition of first 2 bits A0 to the B0, we are getting some S0 and carry C1. So next stage having 3 bits 1 1 A0 and B0 carry C1. So these 3 bits will be added and produce the sum 1 and carry again 1. Next at the third stage, 0 plus 0 plus 1, sum is 1 and again carry is 0. So next 0 plus 0 plus 1, again sum is 1 but carry is 0. So in this way the parallel adder will add the binary number of bits, more binary number of bits at the same time, but each stage requires one full adder. If we would like to add more number of bits, it requires more number of full adders. So that is only the demerit or disadvantage, and also circuit becomes lengthy, expensive. But while coming to the speed of operation will be increased. Why? Because all the number of bits will be added at the same time. So see here one more example is there, 1 0 1 1 and 0 0 1 1 is there. 1 plus 1 0 and carry 1 is there, and 1 plus 1 1, next carry 1 and sum 1 is there, and 1 0 0 sum 1 and carry 1, 1 plus 1 sum 0 and carry 1 is there. So this is more one example. And see here, this is the symbol of binary adder. So while compared to the full adder symbol, in full adder or in half adder it contains only single line. Why? Because all these are A, B, C individual bits. So here A and B having multiple lines means A is not an individual number or B is not a single number. A means group of numbers like 0, 0, 0. B means also a group of set of numbers 0, 1, 0 like that. It having 3 or more numbers. A means it's not a single bit. It is a group of bits. B also group of bits. That's why his bidirectional line is there. Means A is not a single bit. A is also the combination of bits and B is also the combination of bit or set of bits. So set of bits, A set of bits are added to the B set of bits and result sum and carry will be produced. Sum and carry will be produced. Okay. So next, while coming to the next topic, see here. So 4-bit parallel adder requires 4 full adders and it will add set of bits, A set of bits to the B set of bits and sum and carry will be produced. But now we are going to discuss about adder and subtracted in the same circuit. So our next topic is adder and subtracted. So before going to that, once you see here, once we would like to revise the block diagram of full adder and XOR gate. Why? Because with help of exclusive OR gate and full adder only, the 2's complement adder and subtractor must be designed. Okay, with help of only exclusive OR gate and full adder, 2's complement adder and subtractor can be designed. Okay, so that there is a need of once revision of exclusive OR gate and full adder. So see here, exclusive OR gate, already we know that is used to give exclusive function, that means Z is equal to AB bar plus A bar B. Okay, the output is the complement of each other. So and while coming to the full adder, it is used to add 3 bits at the same time and produce sum and carry. So this is the truth table. So here 3 bits will be added at the same time and produce the output sum and carry. The bits 0 plus 0, 0. By adding these bits, sum is carry as well as carry also 0. And while coming to the second case, 0 plus 1, sum is 1 and carry is 0. And while coming to the third stage, 0 plus 1 plus 0, sum is 1 and carry is 0. And while coming to the next one, 0 plus 1 plus 1, sum is 0 and carry is 1. And next stage, 1 plus 0 plus 0, sum is 1 and carry is 0. And while coming to the next stage, 1 plus 0 plus 1, carry is 1 and 0. Why? Because 2 1s are there. 2 1s means 1 plus 1, 0, 1. Sum is 0, carry is 1. Second stage also, only 2 1s are there. But in last stage, 3 1s are there. 1 plus 1 is equal to double 1. So 1 and 1. Sum 1 is there as well as carry 1 is there. So here our 2's complement adder subtractor contains the basic elements of full adder as well as exclusive OR gate. That's why we revise. Okay. So the 2's complement adder and subtractor is constructed with help of full adder circuit and exclusive OR gate. So here the name itself indicates it is a 2's complement adder subtractor. That means what? It is used for the function of addition as well as the function of subtraction. But while doing the subtraction, it follows the 2's complement subtraction method. It is also over. In our third class already I explained what is meant by 2's complement and what is meant by 1's complement, what is meant by 2's complement subtraction. So now this circuit will add the 3 bits at the same time, and while coming to the subtraction, it will follow the 2's complement subtraction method. So once see here, so why it having a 2's complement adder and subtractor having full adder means full adder is used to add 3 bits at the same time, and it is also a 2's complement subtractor. So 2's complement subtractor. Why it is called 2's complement subtractor means the circuit is also perform the function of subtraction, and while subtraction it follow the 2's complement method. What is meant by 2's complement subtraction? So before going to that, I would like to revise what is meant by 1's complement and what is meant by 2's complement, what is meant by 2's complement subtraction. So first of all, while coming to the 1's complement, all zeros are converted into all ones and all ones are converted into zeros. In given inputs, if it contains zeros, each zero will be converted into 1 and all ones are converted into 0. So that is called 1's complement. And while coming to the 2's complement, adding 1 to the 1's complement of given number. This is given number 0001. So 1's complement of given number is 1110. So adding 1 to the 1's complement of the given number, here we are going to get 2's complement. And what is meant by 2's complement subtraction? So in subtraction, subtrahend is there, minuend is there now. So first you should like to take subtrahend, and now you take 2's complement of subtrahend, add the 2's complement of subtrahend to the minuend. So in subtraction, what are there? Minuend is there, subtrahend is there. So minuend means, for example, this is 100 and this is 0011. So here it is subtrahend and this is minuend. So first you should take the 2's complement of subtrahend. So 2's complement means first you take 1's complement, and by adding 1 to the 1's complement, here we are getting 2's complement. So then you add this 2's complement number to the 1's complement. Okay, 2's complement to the 1's complement. So by adding these two numbers, we are getting subtraction of 2's complement method. Okay, so this 2's complement adder and subtractor, 2's complement adder and subtractor circuit, 2's complement adder and subtractor circuit will follow the addition of 3 bits at the same time and 2's complement subtraction. So see here, now already I explained this in the slide also. Subtraction can be done by addition of 2's complement. Complement each bit, add 1 to the result. The circuit computes a plus b and a minus b. So see here, if I consider the bits b0, b1, b2, b3, these bits are subtracted from a0, a1, a2, a3 like this. Once see, so a0, a1, a2, a3. From a0, a1, a2, a3, the bits b0, b1, b2, b3 will be subtracted, and finally we are getting the difference g0, d1, d2, d3. If required, we take the borrow. So b0, b1, b2, b3. So this is the formation of subtraction. Okay, but the subtraction will be done in and while coming to the adder, a0, a1, a2, a3 bits are added to the b0, b1, b2, b3. So in this way, the 2's complement adder and subtractor will add and at the same time will subtract the functions at the same time. So subtraction will be done with the help of exclusive OR gate, and the addition will be done with help of adder. See here, so this is our circuit. Subtraction will be done with the help of exclusive circuit, and the addition will be done with help of, so for that purpose here we are taking exclusive OR gate. So 2's complement getting from the exclusive OR gate, and this bit will be added to the a0 bits. After taking 2's complement of b0, it must be added to a0. Finally we will produce the difference and borrow. Addition is like same, addition is already there. So this is the function. So main advantage of 2's complement adder and subtractor is it will provide both addition function as well as the subtraction function at the same time. Okay, But in both parallel adder and 2's complement adder subtractor requires multiple number of full adders are there. Parallel adder also requires more n number of full adders. For example, n number of bits are added a0 to an, b0 to bn. It requires n number of full adders. Each and every stage requires one full adder. And also here in 2's complement adder subtractor, it requires full adders. In addition to that, exclusive OR gates also there. Cause of that, circuit becomes lengthy and also complicate to operation. And also if any one of the adder will be damaged, total circuit will give the fault result. So that it will be used when the speed is required, but speed is very high. Why? Because at the same time multiple number of bits will be added within second and multiple number of bits will be subtracted, but cost is high and occupies more space and also more number of full adders it requires. So now next topic is serial adder. The name itself indicates here serial. The number of bits, the binary bits will be added serially. In serial adder, multiple bits or binary bits or nibbles will be added serially, bit by bit or nibble by nibble. Here the bits will be added serially one by one. For example, if one example is there 1 0 1 1 0 1 1 1, in parallel adder all the bits will be added at the same time. We are getting the result 1 1 0 1 1 1 1 1 0 1 1 0 1. Like this we are getting whole result within second at the same time. But while coming to the serial adder, first this sum will be produced. For example, 1 0 1 1 is there, 0 0 1 1 is there, 1 1 0 and carry 1. This bit will be sum 0. First bit will be displayed on the result. After this one only, after production of sum S0 only, next second the sum S1 bit will be displayed. After S1 only, S2 will be displayed. That means what? The number of bits will be added serially bit by bit, not at the same time. The first X0, Y0 will be added and it will produce the sum and carry, and the sum will be displayed. And after displaying of sum only, means after getting of bit 1 only, next stage addition will be done. Okay, the next stage addition, x1 y1 are added together and it will produce the sum s2 and carry c2. Next these bits are added to the x2 and y2 and it means carry will be added, and again we have to produce sum s3 and carry c3. Afterwards this carry is added to the x4, x3 and y3 and the result will be produced. Means what? In serial adder, bit by bit the addition will be produced. Okay, in serial adder, bit by bit only, x0 y0, next x1 y1, next x2 y2, x3 y3. Okay, but in parallel adder all number of bits will be added at the same time and produce the output sum and carry. But here all sum bits will be produced serially. S0 produced, then only the S1 produced. Until S1 produced, S2 never produced. So cause of this what happened? The speed will be reduced. Cause of serial addition, speed of addition will be reduced. And here one advantage is there, only one full adder is required. Why? Because adding of first set bit only, second bit addition will be occurred. So after it will produce the sum and carry, then we will take more 3 bits. So only one full adder is required and one flip flop is there. So to store the carry bits. So finally, while coming to the advantages of serial adder, while coming to the advantages of serial adder, number of full adders, requirements of number of full adders will be reduced. Circuit becomes simple and occupies less space, but speed will be also reduced. So here one disadvantage is there, speed reduced, and there is a need of storing carry compulsory. Why? Because by adding this carry only, the output will be produced. So until the application of second stage bit, first stage carry will be needed to store. So for that purpose, here one memory element is required. In our circuit here we are using the memory element is flip-flop. So here the memory element is what? D flip-flop. Okay. So after saving of carry only, after completion of all the elements addition, the memory will be stored the last bit. Okay. So here for the storing of first stage bit, one register is used, that is accumulator, and for the second group of bits one more register is used, that is named as addend register, and first stage bits are applied and we are getting the outputs that must be indicated with help of clock pulse. The clock pulse must be supplied from the control circuit. The control circuit will supply the clock pulse until and unless only the first stage outputs some S0 and carry C0 will be occurred. If some S0 is not produced, it never gives the second set inputs to the full adder. If the full adder will produce the second stage outputs, then the third set bits will be given to the full adder. So in this way, the bit by bit two sets. So after stage 1, set 2, set 3 will be applied. So speed must be reduced, but advantage is number of full adders will be reduced, so that cost also will be reduced. And see here, okay, while coming to the last topic, today's last topic is comparison between the parallel adder and serial adder. The name itself indicates, the two circuits name itself indicates parallel adder will add the two bits at the same time. Parallel adder will add the two bits at the same time. Serial adder will add bit by bit. So parallel add all bits at the same time so that it becomes faster. Serial will add bit by bit, so it is slower. Next, all the bits can be added simultaneously. Already I told you, only one bit can be added. Number of full adders required is equal to number of bits in parallel adder. Because of that, its circuit becomes complex, occupy more space, and also it is expensive, means costly. So while coming to the serial adder, only full adder is required, one full adder. Why? Because one is enough. At a time it will add 3 bits only. After it will producing the sum and carry, the next bit will be received. So these are the differences between the parallel adder and serial. So first one is parallel adder is faster, means speed is very high. In addition, in serial adder it is low, and all the bits get added simultaneously in the parallel adder. In serial adder, only one bit can be added at the same time, and the number of full adders required is equal to the number of bits. Only one full adder is required irrespective of number of bits. The parallel adder, cause of more number of full adders are there, it becomes costly, and while coming to the serial adder, it becomes very slow. Is it clear? So these are the differences between the serial and parallel adder. And see here, while coming to the multiple choice questions you may face in competitive examinations. Why? Because digital electronics is a very important subject. It is a common subject to all the branches. So every competitive examination question paper having the multiple choice question, digital electronic questions. Once see here also model questions. 2's complement adder or subtractor circuit can perform. The name itself indicates, so which perform both addition and subtraction. So what is our answer? C is our answer. So once we check it is correct or not. Yeah, the color will be changed. So C, addition and subtraction. The name itself indicates adder and subtractor can perform addition and subtraction. And see here, while coming to the 2's complement, in the 2's complement adder and subtractor, and see the options. Sign magnitude numbers represent negative numbers Our sign magnitude numbers have 1 as leading bits. The sign magnitude numbers have 0 as leading bit. Or D, 2's complement represents positive number. So tell me the answer. I expect 2's complement. The sign magnitude numbers have 0 as leading bits. So this is the answer. Okay. The 2's complement added subtracted. The sign magnitude numbers have 0 as the leading bit. Sign magnitude numbers have 0 as a leading bit. And see here, while coming to the third one, a logic circuit that can add two numbers. Yeah, we know two numbers. The logic circuit that can add two numbers. Binary adder, subtractor, inverter. Inverter never add, it will inverting, complement. Subtractor will do the function of subtraction. So binary adder will add the two numbers. Okay, so here it is the answer. Okay, so next one, while coming to the third one, state which one of the following statement is true. Serial adder requires only one half adder. A delay line is used in the parallel adder. The parallel adder is cheaper and faster than the serial adder. The serial adder requires only one full adder. Which statement is true? Once see. Serial adder requires only one half adder. Is it true? Serial adder? No. Serial adder requires parallel, not half adder, full adder. A delay line is used in the parallel adder. No delay line is there in parallel adder. Parallel adder is cheaper. No, parallel adder is costly. But serial adder requires only one full adder. So which one is correct? Serial adder requires only one full adder. So this is the correct answer. Next, when speed of arithmetic addition is the main criteria, speed is main criteria, then the adder preferred is speed. Speed means what? Parallel adder. If speed is criteria, parallel adder. Check the answer. Speed of addition is the main criteria, then adder. So serial adder is the wrong answer, no? Parallel adder. Okay. Next, a logic circuit is that accept two bits as inputs and produce their sum and carry outputs. So which circuit? Two bits are the inputs and output sum and carry. So which one produce like that? Half adder. Why? Because half adder will add the two bits at the same time and produce the outputs sum and carry. Is it clear? So next, 7th. Welcome to 7th question. A logic circuit that accepts two 1-bit signals and a carry in as inputs and produce their sum and carry as outputs. Once again, I would like to read. A logic circuit that accepts two 1-bit signals, two 1-bit signals and a carry. I think all of you have an idea. Two 1-bit signals means you consider one is A, other is B, and a carry. And in as inputs and produce their outputs sum and carry. So now tell me how many number of inputs are there? 3 inputs. How many number of outputs are there? 2 outputs. So the circuit is like full adder. Okay. So total 3 bits are there. The circuit is full adder. Let's check the answer. Full adder. Is it clear? So it is very clear. A logic circuit that accepts two 1-bit signals, not set 1 bit. So set means parallel adder, but two 1 bit, only 1 bit, A, B. If it is set A0, B0 like that is parallel adder. But here it is not a set, two 1 bit, only one. That's why it is a full adder. Okay. So next, while coming to the next question, an adder circuit for adding multi-bit numbers and accepting all the bits simultaneously. An adder circuit for adding multi-bit numbers, not single-bit numbers, multi-bit numbers, and accepting all the bits simultaneously. Which one? Parallel or serial? Parallel adder. Simultaneously, at the same time. Simultaneously indicate what? At the same time, all the bits will be added. All the bits will be added at the same time. Okay. So next. So this is about today's class. So in today's class, we are discussed about what? Once I would like to revise. After revision, I would like to conclude. Okay. So in our last class we have discussed about two adders. What are the two adders? One is half adder and other one is full adder. But now we have discussed about two more adders. One is parallel adder, other is serial adder, and other is 2's complement adder and subtractor. 2's complement adder and subtractor. Okay. So while compared to the half adder and full adder, parallel adder is used to add multiple bits, either bit to bit, nibble to nibble, or byte to byte at the same time. But under construction of parallel adder, which components are used? Full adders are used, so that the circuit becomes costly and also operation becomes complex. Why? Because each and every stage requires one full adder. That means what? If n number of bits are added together, it will require n number of full adders. But all the bits will be added at the same time, so that the cost will be increased. And while coming to the serial adder, so the serial adder is used to add the bits one by one, bit by bit. It will perform the addition of bits. Of course, it will add multiple bits, but not simultaneously at the same time. Bit by bit, the bits will be added. Both will produce the output sum and carry, but in serial adder, bit by bit only the addition will be performed. That means after production of first stage output only, the second stage inputs will be given to the full adder, so that there is a need of saving carry every time. So purpose of saving carry, it requires one memory element. So compared to parallel adder, here one additional element is there, memory element, to store the carry. So this is one demerit. Why? Because storing of carry is required. And but one advantage is there, here only one full adder is required. Compared to other parallel adder, serial adder requires only one full adder, but parallel adder requires n number of full adders. Means in parallel adder, number of full adders is equal to the number of bits added together. In serial adder, only one bit is given to the full adder at the same time, but both produce sum and carry. In parallel adder, speed is high. In serial adder, speed is low. In parallel adder, cost is high, it is expensive. In serial adder, cost is low, inexpensive. And while coming to the 2's complement addition, subtraction, our last important one is what? Addition, subtraction. So the name itself indicates it will provide both the functions of addition as well as subtraction. Both functions of addition as well as subtraction. So here, for the sake of addition, 2's complement adder and subtractor circuit also designed with full adders. For sake of subtraction, we take the help of exclusive OR gate. So it is the combination of, means the circuit is the combination of exclusive OR gates and full adders. Exclusive OR gates and full adders. But one advantage is there, it will perform the addition and subtraction of multiple bits at the same time. Of course, the circuit becomes complex. More number, means n number of full adders are required, n number of exclusive OR gates are required. So by using n number of flip-flops and n number of exclusive OR gates, circuit becomes complex. But because of this, circuit becomes complex, but speed is there. At a time, addition and subtraction will be done. Okay. So in today's class, we have discussed about 4 things: parallel adder, serial adder, 2's complement adder, and subtractor. So among half adder, compared to half adder and full adder, parallel adder increase the speed, and serial adder, speed will be reduced, but high accuracy is there, less cost and will occupy less space, and circuit operation is simple. In parallel adder, speed is very high, accuracy will be increased. In 2's complement adder and subtractor, it will add, means it will provide the addition as well as subtraction at the same time, but cost high. Why? Because it is made with exclusive OR gate and n number of full adders. So this is about today's class. It is a combo of all adders. So till this class our arithmetical circuits are over. Arithmetical circuit, what is meant by arithmetic circuit? Arithmetic circuits are used to perform the function of addition as well as the subtraction, multiplication, division, but in our syllabus only addition and subtraction is there. So we finished addition and subtraction circuits. So for the sake of addition, how many number of circuits are there? Half adder, full adder, parallel adder, serial adder. For the sake of subtraction, one circuit is there, that is 2's complement, adder and subtractor. So which one is used to add 2 bits at the same time? Half adder. Which one is used to add 3 single bits at the same time? Full adder. Which one is used to add multiple bits at the same time? Parallel adder. Which one is used to add multiple bits bit by bit? Serial adder. So which with help of which circuit we are going to perform both addition as well as the subtraction functions? 2's complement, adder and subtractor, with help of 2's complement, adder and subtractor. Is it clear? It's very important. Today's topic is, in our next class we are going to discuss about multiplexers and decoders. Already you have an idea about multiplexer and decoder. Why? Because I told you it in the last class. Definition already I give you. So what is meant by multiplexer? Multiplexer means more number of inputs must be converted into the single output. Means more number of inputs will be passed through a single line. And what is meant by decoder? Decoder is used to convert binary numbers, or it will decode the binary numbers into equivalent octal, hexadecimal and decimal forms. Simply it is a converter which will convert binary numbers into octal, decimal and hexadecimal. Octal, decimal and hexadecimal. So in our next class we are going to discuss about this one. Okay, hexadecimal, binary and decimal, decoder. Okay, one last bit is there. See here, in last year question papers we may getting the questions like this. Questions are like explain about 2's complement, adder, subtractor with need sketch. And while coming to our question paper contain 3 marks, 5 marks, 1 mark questions. In 1 mark question the questions are like which adder is which adder will give the high speed. So which adder will give the high speed? Parallel adder. And what is the function of serial adder? It will add the bits bit by bit. Which adder will require the memory element? Serial adder will require the memory element. And which one becomes expensive? Last previous year question papers containing the questions like this. Okay, so which adder becomes expensive? Automatically parallel adder becomes expensive. Why? Because it requires n number of full adders. And which one becomes very less expensive, cheap? Half adder. Only 2 simple gates are there. While compared to the parallel adder and serial adder, which one will become cheap? Serial adder. Which one becomes produce high delay in addition? Serial adder. So having both addition and subtraction is in which circuit? 2's complement, adder, subtractor. Okay. So in our examination 5 marks questions are explain the operation of 2's complement, adder and subtractor with need sketch, and also explain the operation of parallel adder with need sketch, and also explain the operation of serial adder with need sketch. These are the long answer questions. And give the comparison between the parallel adder and serial adder is also one more question. So that is a 3 marks question. Sometimes they also asked that is a 5 marks question. So if it is a 3 marks question or it is a 5 marks question, with respect to of the marks, you write all 5 comparisons. Okay, parallel adder, give the comparison between parallel and serial adder. So total we discussed about 4 differences. Speed is high in parallel adder, low in serial adder. It about the parallel addition serial bit by bit. It requires n number of parallel adder, full adders, parallel adder. One full adder is required in serial adder. So in this way, the speed of addition will be increased in our parallel adder. It will be reduced in the serial adder.